Welcome to another edition of the Crisscrossing Podcast. This is Differential's podcast where we discuss the AI revolution. You join host and innovation strategist Chris Ames, that's me, and Chris Merchick, that's him, as we unravel the mysteries, opportunities, and challenges presented by artificial intelligence in business and everyday life. We are here joined today with Jordan Wade. Jordan is one of our senior engineers here at Differential. As I've mentioned in the last podcast, we do a lot of work in the field of artificial intelligence, and some of our engineers specialize in that area more than others. Jordan is one such engineer. So we thought it would be great to bring him on and just get some insights for someone who is even closer to the reactor of change than we are. Today, what we're going to do is talk about specifically one element of artificial intelligence, and it is something called vector embedding. And so what I want to first do is just ask Jordan, who pitched this idea, what is vector embedding? Why should we care about what it is? And in the field of AI, could you tell us a little bit about it? Give us a foundation or framework of thinking around it.
Sure. So the reason I brought up vector embeddings was that in a lot of the research and readings that I've been doing around AI is this common thread of vector embeddings that has been prevalent and talked about a lot amongst a lot of like CTOs, a lot of the leadership like HubSpot and stuff are talking about vector embeddings. To give you a quick idea of what a vector embedding is, it's like taking a piece of text and distilling it down into a string of numbers that can be represented on a graph. So if you think about like an X and Y graph and you have a blog post and you take that blog post and you can put it into a vector database and it gets assigned a position on this graph. So it could be like 3 and 4 up. And then you get another blog post and you do the same thing. You map this on a graph. Now we have two pieces of content that are text-based, but they're represented by numbers. And now a computer can now measure between those 2 points and determine like how closely like they are similar, how well they match up, or how much they are different based off of that distance. So it's really a way to convert common language, audio, images, music. We can do all these things with all this type of content to map these things to a graph so a computer can understand what these things are made up of and infer meaning from them. So a lot of times you can think of, if you're looking at 2 pieces of content, like 2 blog posts, you might think, well, we can just search those, right? Like keywords of this word is in this blog post, this one's in this one. So inferring that way, like keyword matching and searching and determine if they're similar. In vector embeddings and large language models, that the cool thing about that is that it infers the meaning from these things. So it reads through it and it identifies it in a way that it's basically learned what is inside that document. And then the next piece could be that we introduce another blog post, and it doesn't even have to like figure out what is inside that blog post. It's just assign a number based off of all this other information, and it can infer between 3 pieces of information. The next step beyond that with vector embeddings is that we talked about just an X and Y graph, but in a vector embedding, you can take it to another dimension. So you could say it's a 3D space, or what makes things even more impressive and really cool is that we can have infinite dimensions to determine where these points are plotted in this virtual space. So it basically starts looking like a cluster of dots all over the place. And it can be, like I said, audio, video, images, text, and it starts looking like what you would imagine maybe a brain looks like, or something that all these dots can be measured and connected to and inferred meaning between them.
Yeah, it sounds like when I think of like typical traditional keyword-based searching, it's kind of like watching 2D animation, right? It's like it's 2-dimensional at best. When you start to use vector embedding for something like search, it's beyond 2-dimensional, beyond 3-dimensional. It can have like 10 dimensions or 100 dimensions or even 1,000 dimensions. And so contextually, it just allows something, is what it sounds like. It allows a much richer, more nuanced searching than what just flat, like this keyword based on this definition, and does it even show up in that? So it's like, I can imagine where if I'm searching for a word and there's two blog posts, and one blog post has that exact word in it, referenced several times. And so in traditional search, blog post A would rise to the top. But a vector embedding enabled search may never use that one single word, but it may use metaphors or symbolism or phrases, entire phrases that have the same meaning as the word I searched for. And blog post B would show up in a vector embedding empowered search, if I'm understanding that correctly.
Yeah, and a lot of that stuff can be done. So there's things called synonyms, right? But those are all manually done a lot of times. So there'll be a developer or a technical person go in and start assigning synonyms to words inside your search so that you would get that. With the large language models, it understands language enough that it can, like you were saying, it infers that.
And maybe even I'm imagining I have the Urban Dictionary app on my phone because I'm a little bit older in years and I want to relate to my children.
Because you're cool. That's why you have it.
Cool. It's because I'm not cool that I have the Urban Dictionary app. But it's, my kids will text me stuff. I have 3 kids. All of them are teenagers. And I'll be like, Holt, please. Let me Urban Dictionary this junk and find out. And so,
don't Urban Dictionary junk. Actually. Don't do that.
Well,
Bad idea.
Yeah, like it's not for the faint of heart. I guarantee you. But what I like about the vector embedding search is if it's mapping this stuff and it's learning as it goes, can it learn also as people continue to search and surface new things? It can actually like add new words, phrases, meanings that weren't there before in a way that a regular search might not.
Mm-hmm.
Yeah, that's like one of the things that makes it so powerful is if you create a feedback loop, right, of information. So it starts feeding the beast as to figure out that type of stuff. So it adds new knowledge to its base.
One of the things I was reading just before this conversation, something that like really made it click for me was just the idea of the vector embedding technology being able to recognize sentiment, like that word. I thought like really captured it for me. And that was like, oh, so if I'm writing something, it can recognize that this is positive, negative that I'm writing. It's not just the words. It is like the emotion or whatever what's behind the idea, behind the words that I'm actually trying to convey. So my question for you, Jordan, is like the example that I was reading, some study that was done, or some experiment, I should say, to feed the model, the vector embedding model. They told it whether this series of sentences, this data was either positive or neutral or some other thing. But that's not like a very sophisticated level of sentiment, So like, is it true right now that it could be a lot more sophisticated? Like, is that technology more sophisticated already? Could it tell the difference between this statement or this person is thoughtful versus pensive versus like ruminating or something like that, like 3 words that are like the nuance is very different between those 3 words. It's not just positive and neutral.
Yeah, those are very subtle differences. I don't know if it's that good, but I would say that to give you an idea is that's where it all starts with. There's engineers or data people inputting this information and tagging it and telling it like this is positive, negative. That's like what they mean by when they say they're training the model. And so they're prompting it and telling it what these things are. But then it's almost like a locomotive. Like once you get enough training on it, then it can kind of just start taking off and figuring it out on its own based off of this like base level of knowledge.
So let's talk about that's kind of what it is and how it can help. And it sounds like it's being used in the private sector in various places. What are some other use cases, Jordan, that you know of, like for vector embedding specifically, where it can add power and usefulness?
So we talked about search, and that's like the biggest, most obvious one. Then there's recommendations. There's I kind of hit on as well as visual content. So like whenever you go to Google and you do an image to image search, so you drop in like, oh, I'm trying to find this random product that I found. I screenshot it, I throw it into Google, and it'll spit me out like, oh, this is that product, and it's sold at these stores or whatever. It's using vector embeddings as well to map those images to each other to figure out how they're similar. And then there's also a more recent one that I found actually was anomaly detection for cybersecurity. So we have this giant dimension of dots all over the place, right? So we are looking for we have users inputting information into a text input and they're typing things out, right? And we're logging all this information in our database and whatever. So we have all this cluster of information, and then someone tries to do some sort of nefarious attack through our input or something. So they're trying to type out some code into our input, and we log that. Our vector embeddings, our system can figure out that falls way outside of our graph and identify that as an anomaly and say, we need to shut that down. That's potentially malicious code. And that's like one of the use cases for cybersecurity that came up.
So like an injection, it can detect injections maybe better than some tech in the past could.
It's hard to like abstractly think about how we could use it, but it's just like anything that we have like common use cases, that something that happens in the world often, like we know how people usually interact with the world, like going into a store and doing a specific task or whatever. Like we'll be able to identify like someone acting weird, right? We could use classification information from a video camera and saying the security camera picks up when this person's acting weird, like not normal, like they're not picking up their fruit and putting it in their cart, but they're kind of like looking around and stuff. Like the camera could pick up on mannerisms and stuff and potentially identify that as an anomaly in the system and say, we might have a potential shoplifter on our hands.
I have a friend of mine worked for a company, and they specialized in AI, and it was fascinating work. It did exactly what you said, and kind of the behavior they monitored for was active shooter situations. And so the way I understood it was not only were they trying to like pattern match video feeds to figure out if there was ever an active shooter situation in like a school, a government building, retail establishments, but also they wanted to predict an active shooter before the incident. And so there's a way people walk if they're carrying potentially a firearm. There's, of different sizes and shapes. And then based on like even shadows draped over clothing, etc., you can begin to infer maybe carrying a larger firearm, and then maybe has intent, facial expressions, like you said, pacing, scoping, etc. And what I love about this company, the early detection would send the alerts to like an operations center where trained people would like put eyes on whatever feeds were starting to tweak the AI's sensitivities. And then they would be able to just like with a push of a button, send all the details to the nearest law enforcement to that facility. And I just feel like it's a great real world example. And this company is still developing and that sort of thing. So I don't know how like ready for market this stuff is, but like these are the types of things that could be used to make the world a safer place. But this all sounds great, but surely it's super expensive. It's not easy to, achieve. Seems like it's pretty complicated, advanced technology. What would it take somebody to get some of this up and running today?
So there are lots of databases. So all these vector embeddings need to have a specific type of database. There's a lot of stuff out there. There's open source projects that are out there. Pinecone is one of them. I don't remember any other ones off the top of my head. But as for the price, to do this is pretty easy right now. Like you can go to ChatGPT and there's an embedding section, and you can start dumping in your blog posts, and it'll spit out an embedding, which is like an object with some information and a string of digits to it, and it'll analyze that and do that. And it's like fractions of a cent. Like it's ridiculously cheap to just start creating embeddings. And then you would take that embedding and put it into your Pinecone database, and you would essentially be building up your own vector embedding search that if you wanted to use that for an e-commerce store or something.
So it sounds like, especially on the R&D side, the time is right. And this is why companies are all across the world are really starting to jump on technology like this and personalize it in ways we can't even fathom yet. They're going to discover this stuff as they go. I want to talk about some of we usually in an episode, we talk about like success stories, like AI used in positive ways. So we've covered some of that, but we also like to talk about AI gone awry? What are some of the positives and negative examples of AI use out there lately?
I've got one that it's kind of tied to what we were talking about with the classification or using video cameras to determine bad actors and stuff. So I just recently saw this article of individuals using this in a coffee shop, and they were determining how many cups of coffee certain employees were producing to track productivity. And in a way, for a business, you'd be like, oh, that's a great idea to make sure that to analyze how well our business is running and how much coffee we can serve. But it also, like, how could you use that in a negative way? Like, oh, so-and-so is making more coffee than so-and-so. That person's a slacker. Like, should I reprimand that person?
You're fired.
Not? Yeah.
Yeah. Meanwhile, that's usually like everybody's favorite staff person. It's like the people,
totally.
They give a more custom experience, they're going deeper with customers potentially. And so, it would be it would be wrong to qualify success based on cups served alone, right?
It's funny how even in that, it's sort of not a mundane use of the technology, but maybe like a more ordinary use, maybe, is like somebody helping to optimize business operations at a local cafe or coffee shop or something. But though that's true, it's still sort of high stakes if you're talking about people's jobs, like you're going to make a decision whether to maybe not just reprimand, but to fire somebody if there's this pattern of behavior or something that you think is not optimal. So it's kind of interesting to think about even those circumstances.
And we've been worried about our robot overlords for so long. And half the people are like, no, beware. And the other half are like, I'm tired. Let's give the robots a chance.
Yeah, totally. Totally.
It just depends on the day of the week where I land on that.
Yeah, for sure. Jordan, do you think there are any other significant limitations, or maybe another way to ask it would be like, are there any areas, we talked about the search, the recommendations, other things, are there any other areas that you think like, oh, this probably isn't a good fit?
So facial recognition is something that's been around for a little while, but the new implementation of it with using AI to actually like determine if these things like line up based off of measurements of eyes and where the nose and where the mouth is, that's all fairly new. And I think the problem with an implementation like that is that we're still dealing with a data set. And a lot of these data sets aren't fully representative of the entire population of the United States or the world. Like a lot of them are just trained off of a specific niche or group of people. And so I think in this case, with what you're talking about here, is that a lot of these models don't have fair representations of Black and brown people. So they just innately just don't know the differences of what people look like with darker skin a lot of times.
Well, I think it extends even beyond that. There's biases that are baked into the data, not intentionally necessarily, but they're just there.
It's from the available data that are entered in. Yeah.
Yeah. I read this article. It was talking about vector use in large language models. It takes words and reduces the words to a number so that you can kind of do quote unquote math with the numbers that represent these words. And then the numbers are like these coordinates in like multi-dimensional space, but you can tell proximity. And so it talked about if you do something like biggest minus big is equal to plus small equals, and it'll do smallest, right? So biggest minus big plus small equals smallest. And it can figure that stuff out because of the proximity of big and small spatially and adding those the ends to the words. But then if you do other math like doctor minus man plus woman equals, and it will naturally say nurse, right? Because of the data that it's been trained on. And so there's this bias in there that wasn't put there on purpose, but it's still there. And so I think researchers and technologists these days are trying to kind of factor out these biases in the data and the data sets in order to make them fair and representative, to your point, Jordan, to make them more representative of like the way the world maybe ought to have been all along in some cases.
It'd be fascinating to see like the actual like the computation to see the individual data points that it looked at. And then you could go back and say, oh, here's where it got off. Can you do that?
That's one of the hard things that a lot of these large technology companies are struggling with. So with the regulation and policies that our government is trying to put in place, they want to know, like, how did it go from A to C? And really, a lot of this large language stuff is kind of a black box.
I don't know.
They can't really, like, because of the technology, it's just inferring things and like this giant guessing machine. So, but if they want to regulate it, and like, you have to tell me how we got here. So whenever we get to a case where there's facial recognition issues or whatever, how do we infer, like, what was at fault here and how do we fix these systems?
I don't think this is perfectly accurate by any stretch, but the way my brain sees it is like in traditional programming, you'd have an algorithm, which was almost sequential in a way with maybe some recursive loops where it's just, like doing this step-by-step linear computation, And these days, it's almost like parts of the algorithm are self-writing code in a way. The way it's more like it's self-generating data, but it's because it feels a little bit more organic, for lack of a better word, than it used to be. And so how do you go back and find the error in the math equation when it wrote itself to some degree in the middle? It's like you said, Jordan, it's a black box at that point.
I mean, you're talking about like billions of parameters and information. So that's like it's just so massively huge. That's why they call them LLMs, large language models, is that they're so big that it's nearly impossible for a human being to dig in there and narrow down where the rabbit went down the hole.
And then, so meanwhile, you get on Midjourney, which generates, like AI-based art, and you ask for it to spit out an image of an average woman. This is something you brought up, Jordan. We were talking earlier last week, and it shows basically a supermodel, like what some people would consider a supermodel.
It actually came up again this week, like me searching through Reddit and stuff, and on the Midjourney Reddit, and someone did one for it, and it said average woman from each planet. And it literally, it was almost the exact same face every single time. And it was like a supermodel in like a red astronaut outfit, like for Mars. It was so terrible. Not even close to what you would expect.
Jordan, it has been a pleasure having you. Thank you so much for teaching us a little bit about vector embedding and bringing the topic, and just really appreciate your insight and expertise. So thank you so much for joining us today.
Thanks, Jordan.
For sure. Thanks for having me.
For the rest of you, if you're still listening, Differential is an innovation studio. We have engineers like Jordan and others ready to just jump on your products. We have product designers. We can deliver and implement as well. Our mission is to rapidly unlock value for good people with meaningful ideas. If that sounds like you, we believe you're a good person. But if you have meaningful ideas, don't hesitate to go to differential.com and check us out. Thank you so much for joining.